and I think we can move on to the next, let me check. Okay, to the round table. And we will have basically 3-4 topics. And like everyone online and here to have a say in these topics. So the first topic will be about PFAS substitution and material sustainability. Some of the questions that might be about alternative to PFAS. I think this is exactly what was the last question about also, and also what we basically do in membranes, ionomers, and so on in this project. So maybe I would start with one question for anyone from the HYScale project who would like to answer it, and then we can have just a discussion on it. And would be, in your opinion, which is the characteristic that at the moment it is the hardest to replicate while maintaining all the others in the PFAS-free substitute? Before giving you the word, I would like to remind you, everyone, let me just take this a little bit more. Yes, that there will be a whiteboard session in the sense that everyone can write their opinion. I will share the link. If you have problem with the link, you just ask for the authorization, like some of us are already done, and you can, and I will grant you the permission to access it. This will happen in a few moments. So the question again for HYScale project is, which is the hardest characteristic that it is the most difficult to substitute for the PFAS, or the one that we need to compromise? I don't know if any of you would like to take it, or online.
Yeah, I would say for the balance of plant, when you want to have coatings for the stainless steel, for example, this is most easily done with PTFE, or you have also some PTFE tubing, and this all needs to be replaced. So I think this is a big problem for AM electrolysis, where HYScale is working with. I think most of the parts are already PFAS-free in the cell, and we also have for the cathode side not really a problem. I mean, the MPL is a big problem, and the GDL like you described, but we can in principle also use just nickel mesh on the cathode side. So this is just PFAS-free then by design. So I think the balance of plant is the most problematic for AM. And also gaskets, the whole stack itself, yeah, this can be problematic.
Yeah, more thought about? No? So is there anyone from FASTCH2ANGE would like to say a few words also on this? Antonella.
Okay, maybe because I'm actively working a lot in the validation test and also manufacturing of membranes. Let's say that the compromise between the stability of the membrane, the contact between the catalyst layer on the membrane also, and developing PFAS-free materials is always a big challenge, because of course fluor is very good in in making a good balance between the hydrophobicity, hydrophilicity, mechanical stability, swelling, and so on. So I think that also one of the major, I would say, one of the major problems that we're facing with these technologies is also trying to make a good membrane with good proton mobility, mechanical stability, low swelling. This big compromise between all the characterization that has, all the characteristics that has to have the membrane, and also, of course, reproducibility. And if we think bigger, if it's cheap or not, and so on. But there are many things that are important when we talk about the technology for removing PFAS. Yeah, thank you.
Thank you, Antonella. From PROMISERS side, is there any comments?
Yes, I can agree with this. So the main issue is with the long-term stability. So materials, we know now that they are very stable, also in nature, and they are coming back to us. But so to find different materials that have the same properties is quite challenging. So you need so there are materials that are very good, but then you have problems with swelling or long-term stability. So that's the main one of the main issues to find some materials that can perform as well. And also, if you look at the PFAS materials, so membranes are made using not very toxic solvents. So what we see is that when we want to use new materials, normally quite some toxic solvents are used to be able to make some membranes. So this can be an issue. And we also saw it with the bio-based materials, so they don't perform that well, and they have problem with high viscosity and also swelling. So
Okay, thank you. Anyone else online would you like to say something? Or is there any feedback from everything that we have said? Okay, so another question that I would ask anyone willing to answer would be about regrettable substitution, in the sense that have you seen that, you probably seen that sometimes when we want to replace something with something that looks better, for instance, when first the Teflon pans were invented, about trying to improve upon the usual common pans, sometimes we go for the worse. So how should, for instance, a project deal with the regrettable substitution without reaching the end of the project and saying, okay, we understood only at the end of the project that this substitution would be, because usually this is the case, because it is difficult also to have enough time to understand in just a few years what could go wrong in the next decade, for instance, because also this was the case for the first company that invented the PFAS. They didn't want the world to burn, to be destroyed for sure. They wanted to improve the world. So, but they understood it only later on what really happened. So I don't know, is there any thought about this? How can we speed the understandable of substitution about regrettable things? One thought might be, because also in our project we have digital tools, but also digital tools needs a lot of time to develop a real understanding. And even when we think about everything overall, it is impossible to state, okay, this is completely free of hazard. For instance, another case that everyone my generation remembers probably is the hole in the ozonosphere, because also in that case, everyone thought that having a refrigerator, having a gas that worked in a certain way didn't impact anything. Maybe they understood of the environmental nearby, but they didn't think about what would happen in the atmosphere, in the ozonosphere. So there are still some blind spots about this. So my thought would be, for instance, that even though we can have digital tools at the beginning of the project, we need probably 3, maybe even more than 3 years of the whole of the project to do everything in our power, to consider every possible angle. And so even if digital tools tells you, okay, this is safe, this is good, we still need to a life cycle assessment everything that we know, because there is a lot of things to know. And I think that maybe in the next workshop, because we wish to have more workshop with sister projects, if there is any trouble, any lesson learned, we can learn together and speed up about this as well. If there is no other comment, yes, we have Fabiola.
Hi. Yes, this is indeed a quite important issue, because then surprises might come later in the project. And I think what we learned from another project recently closed about SSBD coatings, and it was to substitute PFAS. So we checked all our ingredients, let's say, that we were using since the beginning. But then for me, that was new. We learned from our colleagues from more toxicology, etc., that although we have the REACH and ECHA list, then sometimes if things are not already certified with a certain danger, they do not there. And there is a link, now I don't have it in my mind, but where you can see when people from toxicology, etc., field find that some substances might be dangerous, they declare it there. In some cases, they just say it might be dangerous. In some cases, they put papers or what they did. And it's quite interesting to check this site. So with the help of our colleagues, we could check. And in some cases, she told me, okay, this is not certified, but I can see that these experiments are quite valid. And this is something that might seem laborious, especially for us who are on the side of just, doing a solution that works well, but it might be worth it, because then there might be ingredients that are not reported but have some problems. I mean, that will always be anyway, but it's just one step more to check.
Yeah, just to maybe add a little bit, which I understand is more or less from the concept of input-output. And also from the example you gave about the pans and the refrigerators and all the rest of it, it comes from the perspective that from a commercial standpoint, you are so much focused on the profit that is going to be derived from this, that we neglect what is the input and what is the output. Basically, understanding what are the things I'm actually putting in this, what is this environmental impact, and then on the outside of it, what is it releasing to the environment, what is it causing. But by focusing only on, okay, from a commercial perspective, this is what it's going to do for us, we may be achieving one thing while shooting ourselves on the leg on the other. Thank you.
Thank you, Daniel. Thank you, Fabiola. Yes, and I would also like to read a comment that online Erasmo Napolitano left. He wrote, unfortunately, high chemical and mechanical resistance go often hand in hand with how hazardous a substance seems. Greener chemicals have the exact problem of being degradable, and the challenge is precisely to make them more resistant. So this is exactly the problem also of durability that might be another question down the lane. Yeah, and also I might add also to when Daniel was speaking, I thought about it, the fact that even though we do the best life cycle assessment, probably we are not considering everything because we are given we are learning year by year that there are more and more risks. Yeah, I've seen one raised hand. I will finish my concept and leave the floor to Marcel. The fact that not every time we understand that there might be a new risk that we are not considering. So it is very hard for us. Marcel?
Yes, I want to comment on this because it's quite challenging, because we have seen in the past a lot of examples that we use new materials. It seems very promising, and then it seems they are very toxic. So we have seen it with asbestos, which seems very interesting, but then it was making cancer in people. So also with solvents. when I started in membranes, NMP was regarded as a very safe solvent. They said you could almost drink it, and now 25 years later, it's also carcinogenic. So. And when I was talking at that time with my professor, they said when I was young, I was using benzene to wash my hands in the labs, and when I started, benzene was already on a blacklist. So yeah, you can see in time this is changing. So this is also happening with new materials. As soon as we apply them and we have more data, we can then see if it's toxic or very bad for the environment. But yes, sometimes it's a challenge. So. Then we can use bio-based materials, but then they degrade very easily, and so yeah, it's quite a challenge, I would say.
Yeah, exactly. Thank you, Marcel. Okay, we have another comment.
Yes. So hello everyone. So the question is how long really we want to have the operation of the electrolysis So I mean, we're always heading for a really long time operation, but when we go for less dangerous materials, maybe also short operation would be okay, then a nice recycling and then building up again. So this is also something to consider. So less dangerous, less PFAS, but maybe short operation. And if this would be accepted also from the customers, I think, yeah, they won't accept, I know. Yes, but when everything is very cheap, so bio materials like operating for some thousands of hours, then we can just do another cheap system and replace just the slack. So maybe this could also be an idea, because we're only heading for very long-term operation, problematic materials, but maybe we could also go another way.
Thank you. So Farhan was talking about how much short-term was short-term, and so you were talking about 300 hours. Yeah, exactly. Okay. Okay. Yeah, because I think this might be the best path, because as Erasmo was saying, the more durable, probably the less greener they are, and the more greener, the greener. So the greener, the less durable. So probably the idea of having something replaceable would probably be. And I think it's not something that is outside of the commercialization, also to touch topics about industrialization and commercialization, because when we think about, I don't know, phones, people change phone quite often. Maybe not me, but yeah, they usually do it. And there is a lot of advertisement about this, having the newer version. In this case, of course, it is not a newer version. It's just like to be considered as a consumable, like, I don't know, a bottle of water, something that you need to replace when it is finished. So yeah, and probably is best than just having the alternative, because we all know that when everything looks too much successful, like in the PFAS case, in the case of asbestos, something that looks very perfect, durable for eternity, it is something that we need to fear in a certain way, because we do not know what will happen, and history teaches us never to lower our attention. Just to give another example, I don't know if you know about thalidomide, maybe. It was some drug that was prescribed for women that were waiting for their baby, and they thought it was just a calming drug. Instead, at the epoch, they didn't understood already the concept of enantiomers. So they didn't understand that there was some gravity in what they were doing. So this is not about durability as a concept, but it is a concept about that there is always an unknown that we cannot predict, and even if we look at every possible aspect. And from my side, the lesson that we should learn is that even if we have passion and we have constructed and built something very good, I don't know, we will find a PFAS substitute the moment we understand there is something that is suspicious, let's not do it like the company that invented PFAS, because at a certain point they understood it and they just hide it. Also, so because we do not have to confuse passion to something that we have created with the fact that there will be a consequence. Okay, sorry, too much philosophical. So now we were talking also about commercialization and industrialization. So about, I think upscaling is probably the key point where we need to understand what is the potential, because our projects, I think all of our projects will end at TRL4, maybe 5. There is someone reaching 5, and then there will be the upscaling program. And what is, in your opinion, the bottlenecks, the main bottlenecks about this upscaling, in the sense that everything works on paper, everything works in the lab? What is something that you expect to be the most important bottleneck about this? Is there anyone who wish to? Yes. I'm like I have long arms.
Yeah. Maybe a short answer. I mean, of course, there are a lot of issues when it comes to upscaling, but I think in the hydrogen markets, the biggest one is that the market is still missing, and we need a lot of a market in order to even scale up and get more first experience in the first prototyping, first generation, second generation, and we need a lot of products in the field to have really real data. And yeah, we cannot just do everything in the lab. We need the market there to have a first generation out there and then to further scale up. Because what we have seen now, that a lot of companies, they are ready to produce, at least on paper, megawatt electrolyzers, but the market is still missing and they need it. Yeah. So this was about like from my point of view, but maybe some other comments on that.
Yes, I totally agree with Stefan, and I believe that this is not only, not mainly related to a technical gap, in the sense that we are not talking about scaling up some complex processes for attaining those materials. But this, and I think it is mainly related to the cost on that is dealing with the adaptation of the existing production lines, because we created basically from scratch our supply chain for the production of electrolyzers components based on previous knowledge, and now we need to change it. And this is something that should be seen also when it comes to policy orientation. For example, if some kind of small medium enterprise or another kind of big enterprise should go in the direction of the development of PFAS-free components for electrolyzers, proven to be effective at low TRL scale, it should be also clear that if once want to go towards the direction, you need to also have clarity on the framework, the political framework, and the stability in that sense. Also because I'm not super sure that the PFAS ban, for example, would be enforced by the 2030 deadline that is under discussion right now, since it might cause severe disruption not only in the hydrogen market, which is now in a more steady state. Let me call it by that. So the problem is much more related to the driving force to the market. I would say not from the technological perspective, but I'm open to argue with that. Please, Marcel.
No, yes, I agree on you. I think it's also very important to hear the end users. So if you are if you are a company that operating a electrolyzer or a fuel cell, and there's the option of a PFAS-free system, but it's unknown how long it will last, and if there are extra costs, are they willing to invest in something more environmental friendly, or are they choosing for the standard technology that is performing maybe better and is cheaper? So I think it's very important also for the awareness by the end users for which system you are going for. So
Thank you, Marcel. Okay, the important part is to listen to us. Okay, no. There is a comment in the chat from an anonymous attendee. I think in gasket materials, promising results are obtained by the point of view of catalysts. With bismuth nedodecanoate, we replace the dibutyltin dilaurate, which contains an H360 carcinogenic agent. I think it's just a feedback. It talks about also the soldier compounds. I think it's a comment from, Andrea Rosati, yes, for the FASTCH2ANGE project. So it's talking about the fact that also we need to look at not just PFAS, but also other aspects about toxicological aspects of the overall process. So yes, removing carcinogenic and avoiding carcinogenic agents for sure, even if in catalytic conditions, is very much important. Thank you, Andrea. So I think talking about compounds and one other aspect, I think it was in HYScale that you had CRM3, compounds, because one question might be, in general, from two point of view, both a geopolitical point of view, especially in this, to avoid certain dependencies, and the other might be also from my point of view of universality, in the sense that you do not need to depend whatsoever on materials that are not there. For instance, it is needed to be accessible. So I don't know, from your side, from HYScale thinking, what is the hardest or the difficult CRM to substitute, or any comment about this topic, about maybe go a little deeper if you want.
Probably start. Yeah. So from HYScale perspective, the two points you mentioned are quite important with regards to CRM3. One is, of course, the geopolitics involved in these materials, and two is a function of cost. Generally, CRM3 materials are relatively cheaper than these platinum group materials. And since you're also talking about cost and market, it's very essential that the hydrogen is very competitive to conventional hydrogen that we have currently. And for that to happen, then the materials itself needs to be also competitive enough. So that is where the CRM3 comes in. I don't know the second question.
No, any topic about CRM, yes. Yeah, my comment would be that for the CRM list, we should also be aware that not every material that can be used in electrolysis is on that list. So, no, really, because when using like an old list for proposals, we can still use more materials. But at one point, when also we have nickel, titanium, everything on that list, every material we need to use is on that list. So we will not be raw material free. Yes. Yes, and in Europe we also make it then very complicated for for our industry to produce anything. And the others like China, whatever, they don't care about that. And they produce very fast megawatt scale stacks without any problem. And we have so many regulations that this can be a problem. So I think this is also something to consider. In principle, that list is good, but
yeah, okay. So yeah, thank you. About regulations that you mentioned, the regulations. Besides CRM, is there any other thought about the fact that usually, I don't know, before using a certain new component, you need to follow specific regulations and maybe delays in the commercialization. Is there any comment on this? I don't know. 1 second. Yeah. I like to walk.
Yeah, I think specifically there are regulations, of course, involved. I think that's one of the things that we usually find when we are trying to increase the TRL for certain technology or certain components and everything. That's the first thing that we came into like face that, okay, how many regulations that EU has that we come across, and then it delays the process in the upscaling. So for example, as example mentioned by Tobias, that China, like they do it quite fast. I think one of the reasons is that there are less regulations. Okay, it's nice to have those regulations that you can, because it kind of like control things, but at some point you have to slightly give more flexibility when you are increasing the TRL, because then once the TRL has achieved, then you have the more chances to do those kind of things, to have the regulations. There are kind of very different regulations that might, I think, kind of hinder certain things, and then you cannot progress beyond that one because of that regulations. So I think that's the kind of the generic overtake on this one. Do you have anything?
Thank you, Farhan. Is there any other comment online? Okay. Otherwise, I think I would like to delve into the harmonization of testing protocols, for instance, and and Stefan has a slide to share from my computer. Yes, 1 second.
Yeah, so now we're talking about protocols, harmonization. I mean, it's already stated in all European projects, and I think it's really important that we work here together. And yeah, so today I would be really, yeah, okay. I just copied here really quickly some things that we are part of. So one, of course, is the JRC report as well. We just got informed that there will be a workshop in the 30th of September. So everyone who is interested in testing, maybe can be you're not seeing it?
I think we just
slow, but I mean, as well, I can explain it, what we see. So we have like of course, the JRC harmonization that's going on, but as well like the EAA task 30 is something we are part of, is as well developing its harmonization standard. And I think it's really important if we discuss, and I have like here 2 questions that I find really interesting, so that we discuss what do you consider as the most critical feature of a well-designed protocol and why? And the second one is what are the most common challenges and limitation during the protocol development? Yeah, so maybe we start with the first one. What do you consider as the most critical feature of a well-designed protocol? Are there any comments on that? No one?
Come here.
Fun.
Come here.
Maybe.
Here.
The feature for the well-designed protocol is the that how streamline are the processes or to kind of consistent among different partners. So that's one of the in my opinion, it's the important part, because we all do the results, but then our methods and everything could be a different, and that should be like the reproducibility of the results could be achievable, and that's not that why we need this test protocols. And the other thing is the like setting up the examples for the future work, because EU releases the like the requirements overall very generic, like within the range and certain kind of limitation, but it's good to have it very specific, like for this PFAS free, which is very kind of new in materials development phase. And then similarly, I'm involved in the direct seawater electrolysis. So there it also needs kind of like the protocol harmony and then everything in that case. So that's kind of the two things, in my opinion, that we need to streamline the results and reproducibility, and then the kind of helping the future project, their future work, and also the data.
Okay, thank you. Then there's another comment.
Okay, so it's also very important to think about what you want to test. For example, if you want to test a membrane and compare it between different labs, for example, should be the same. Or let's say the catalyst should be the same when you compare just membranes. When you compare different catalysts, the membrane should be the same. So I think these are also very important points to compare new developments between different projects, because otherwise you will see too much influence of balance of plant, cell hardware, and everything. So this is also important to consider.
Yeah, thank you. I think that's a really important point, that we are not only on a one-dimensional field here, that we have to think about the test cell, the whole test bench, like the balance of plant and so on, and then the test protocol, and all together, then maybe we can have reliable results to compare. And I think it's a really crucial topic as well. If you think of generating more data, maybe we want to use as well AI for helping us finding the best combination or do further simulation. For that, we really need high quality data where we can rely on. And so therefore, I think it's really crucial that we put more effort into that and talking a lot together and find out the best test hardware, improving the comparability of the test bench as well as the test protocol, and focusing again on test protocols. In my opinion, is that, I mean, in the end, a lot of doing almost the same protocols, so the protocols don't differ that much, but still due to small different materials, different requirements, they change. But what we need is to improve better into explicitly describe what differs, that we can say, okay, this is like the basic protocol, and now you are allowed to change maybe these parameters, and then it's specified that we are sure how we can compare it and what kind of parameters are influencing. And so I think there's no way that we can say there's one harmonized protocol and everyone is using it, but maybe we can see it's a harmonized protocol with fixed key features, and then you are allowed to adjust, and that we are used to how we describe on a standardized way how the protocol looks like, because otherwise it's just hard to say. And as well, like we are doing that internally now, our protocols look really similar, but still we have small differences. Sometimes we say, okay, I need to speed up a little bit and so on. So this is like a daily work that looks a little bit different than having like a perfect standardized protocol that you can use each day.
I have a question for you. Okay. Since you were talking about the fact that, of course, it's possible to have some great degree of liberty, of freedom, sorry, thinking in Italian, of freedom, which is the parameter that in the case of, I don't know, membranes and electrolyzers or something that, in your opinion, the parameter that should never be compromised in the sense that should always be fixed in the protocol for electrolyzers and so on. Is there anyone parameter?
I think it's really difficult to say, yeah, because maybe, I mean, if you want to compare data, then we have to agree on a certain temperature level. But as well, still we can say, okay, we want to test something on a lower temperature. But if you want to compare the data same temperature, I think is crucial. Then test hardware, or at least that we say we agree on certain conditions. So same clamping pressure, pressure distribution, and so on. This is fixed. And then I would only say on that we say we have a defined break-in procedure to do the conditioning of the cell, and this already differs depending on the material. Some membranes need only a few hours, others like already a few days. And as well, then the big question is, what is like your maximum operation point? I mean, if you want to have a good performance, best performance, maybe you don't go to higher current densities because then you see already initial degradation. So I think this is everything you have to take into account, and yeah, so there should be fixed parts of the protocol, but how they look like, it should be really this way described. What is like the maximum power point? What is like the idea behind it? Why do you test it like this? Yeah, that as well. Like others know, for example, why was it that short? Was it because of the test bench capacity? Was it due to that after a long iterative cycle, we found out that this is the best break-in procedure, for example? I mean, everything should be clearly defined and understandable for the whole community to improve again.
Thank you. Is there any question, comments, or feedback on this? Let's check. Yeah, there is something in chat. We can see the presentation. Okay. Okay, there is Marcel. Marcel?
Yes, I can comment on this. I agree totally with the previous speaker. It's very useful to harmonize the protocols, but yeah, due to different hardware in different locations, there are many times difference in results that are obtained. So we see that also in the PROMISERS project. We have also harmonized the protocols between the partners, and we still see some differences due to some small changes in maybe environment, also hardware, and also testing protocols. For example, if you have the Fenton test, how do you test it, and which chemicals do you use, and how long, and which concentration? So yeah, I think it's quite important. But yeah, you have to keep in mind with the little differences that you can obtain then different results at different locations. So.
Thank you, Marcel. And there is a comment.
Yeah, just a small comment that for the research community, it would then be nice that at least in the publication, everything is clearly stated. This is very important. Yeah. But yeah, sometimes it's not.
But then there is also difficulty of acceptance that some researchers or institute wants to, or like the way they're doing things. Then harmonizing them between create like it's not somebody's ego, or it's not, but it's like you have to change the way that you have been working for a few years back.
Yeah.
So that change might be a bit slow, and then it takes time to adjust. So that's another difficulty usually.
Yeah. So before, Fran was saying that there is also some inertia, in the sense that even though there are new protocols, that we have new recommendations, for instance, it might be hard for those accustomed to do it in a certain way to change. Okay, so there is a comment. Yeah.
Oh, okay. Just a little brief in addition to what said. is the fact that changing protocols makes it difficult for you to maybe have it, for you to compare the results you have before. So if I have 100 data sets previously, and then I have a new protocol I have to change, even if it's as simple as switching from governor static to potential static, it immediately makes it difficult for me to compare with my years of results. So in that case, I also have this inertia, like he said, to quickly jump into the new protocol, just as an addition.
Yeah. Just a comment about you. I was in another project about the fact that they were talking about protocols about hydrogen permeation, and one specific partner was so accustomed to use derivatives of arsenic during the permeation that they didn't want to listen to improvement, because they said, no, we have tried other things, but it is hard to see the things that we want to see in a very clear way without having these arsenic derivatives, because there was a previous protocol, I don't know how much older, but that used arsenic derivatives. And so I understand there's some, yeah, there is always a price to. Yeah, there are just.
You have different components, like a water components, then you have to streamline it.
Okay, so Fran is a bit shy, but I will try to convey his perfect example, because he was saying the fact that there are newer ways, there are improved ways, in my opinion, also because arsenic derivatives should not ever be used again, in my opinion, but for the risks, but yeah, to streamline a new process. Is there any other comment, feedback on this, maybe? Yes, Antonella?
Just a small comment. It's really nice we're talking about protocols, because we're all following protocols, and I think there are two things that for me are very important. The first one is details. The details on the protocols, because you see, following this protocol from North America, for example, we do this, and there is no much, I would say there's no much information. So what do? We do our internal protocol, which you follow for some years, and then it's sudden that, I don't know, some part of the protocol changes, so you have to change a lot. And I think talking about this is a good thing, because it's a growing moment of these technologies, and it's a good thing, but it's quite important to pay attention on that, and also to have it present when we use commercial components, let's say, because sometimes the information they give about the material they're selling, let's say, doesn't go or it's not related to results that we would think of having from the protocols. So maybe, for example, we're talking about let's talk, for example, membranes. When we buy membranes from a company, sometimes the information they give from this new material doesn't agree with the protocol that should follow, maybe. So this is also not against, but in conflict, let's say, with all the protocols we follow for that. So it's a good thing to keep it in mind, because it should be for like a benefit for all of us. So it's just since we're talking about this, I had this kind of trouble, let's say, when being in contact with companies that they sell membranes, they sell, I don't know, CCNs, they sell electrodes, and maybe the characterization they do, even if the companies are from Europe, maybe sometimes they don't follow the protocol. So it's a good thing that we are talking about now, because it's something that we should all be aware of it, because at the end, we need to follow something. We need to have parameters. Yeah.
Give that man a microphone. Yeah.
I mean, one suggestion could be that we can make those protocol documents like as a living document, which means that you can go back and update during the duration of the project. So not like setting in stone at the beginning, because that makes very difficult to, because you don't know, you are trying new things and everything. So there might be some improvements in there. So what I have seen is that if you make that document like maybe once in a 6 months or once in a year, to by like all the partners who are developing the materials can go back and see that, okay, what we have stated in the initial stage, does it still valid, or does something has changed or something? So that's kind of like to overcome these kind of like a difficulties, then that's one solution to it, to make it like a living document.
Yeah, and then maybe one last comment from my side. I think it's all really important and valid points, and we still, it will be challenging in the future, and we really have to work on that. And I think documentation is the main important point, that we say, okay, we do that, but as well, we know time is limited and we have a lot of things to do, and then maybe sometimes documentation is not if it gets too complicated, it's not really practical in the lab if you work like this. But I think as well, we have to think of that there is not only one perfect harmonized protocol. I mean, if you have a final product that is almost can be in the market, then of course one protocol that is the same to benchmark it. But if you like have new materials in research, then for us, like we want to benchmark a lot of materials, and then maybe we have to reduce the time, we have to speed it up. We want to like get the best results out of our test bench. So maybe we have additional steps in it in order to get more insights and so on. So there are different requirements, and then as well, maybe we need different approaches, different protocols. But in the end, what is important that we kind of know what can we compare and what are the differences, and then we can of course improve our work and the guidelines, how we can state the differences here.
Yeah. Thank you, Stefan. So to summarize, in my opinion, about the protocols, about the regulations and the comparison with other countries such as China, I think we can still remember the fact about regrettable substitution. So it is important to have regulations, it is important to have testing protocols, it is important to have something that checks every parameter, because in this way we can know the problem. So I think one last session, and then we can close. I recommend each of you to write something on the post-its meanwhile. But I have one question. I don't know if also Matteo is still online. Otherwise, okay. I have one question for everyone of the 3 projects. Let's imagine that the project is ended 2 years ago. You have reached your potential. You have reached your whatever you have thought about your project, and you have a product that now is being commercialized in 2 years, maybe 3 years. I don't know. What is the thing that you are most proud of? What is the added value that you have brought to the market with your project? What is something that stands out for your project? Would you like to start? Okay. So your dream has come true.
I'm
happy.
At least from the perspective of SEMMAD, our dream has come true a lot of times. And the HYScale project also made it possible for us to showcase the PFAS-free membranes, as well as the long-term durability of our catalysts and CCS. So for us, if I say happiness or our gladness will be that we have a large customer base that uses this product, not just the fact that we have produced it, but seeing how every other person or the community is using this product and how it is generally impacting or affecting the society. So that for us would be the highlight.
Thank you. So from PROMISERS, Marcel, do you want to take this question about what is the thing that you are most proud of when your project will realize, will reach its full potential at the end of the project?
Yes, so for me, it will be a success if we can come up with some materials that can be very promising to substitute the current PFAS materials. So that we make a step forward and to a better environment, because there are a lot of problems, as you know. So there are a lot of issues, not only PFAS, or also microplastics and other problems we talked before. So I think it's very important to have a better environment for humanity, to that we can live better and don't have so much issues regarding toxic substances that are in the environment. So for me, it would be something, if we can reach this, bring it a step forward with the PROMISERS project, I would be very happy.
Thank you. So Matteo is not online, so I would like to ask the question to Antonella, Fabiola, Alessia. Would any of you would like to think about the, I don't know, FASTCH2ANGE has finished and you have reached your product, which is being commercialized in the most possible, in the best way possible, in the sense that there is no toxicological effects and so on. What are you most proud of?
Proud of everything. Everything. Proud of the consortium. So it means that not only the materials are available to be commercialized, but also all the methodologies for the AI-driven platform, and also the methodologies implemented for the characterization work well. And if there is a result like this, I think that the goal of the project is reached.
No,
I think I already said the problem of the consortium, so I think it's very difficult to pinpoint one specific thing.
Yeah.
There is a multitude of a lot of things.
Okay, so I think there might be some problem with the whiteboard. Some of you are online and already written something. Some of you have troubles entering it. So I think there was a lot of feedback, and I loved the idea to have this active participation. And I think that from the recording, Maria, we can derive each comment. So for those of you who hadn't the possibility to write anything on the post-it, I think we can derive it from the recording and the transcription. It might be a good idea. What do you think, Maria?
Yes, okay, it's a good idea.
Okay. So is there any other topic that we haven't mentioned yet? Yes, there is one, actually. Collaboration, future collaboration. I think this was a very productive meeting, and I thank each and every one of you and your projects, and especially Maria for fire of organization. And we are thinking, and we have already some good feedback from Technalia, that we can have this workshop in other 6 months. I think we were thinking about having a poll for deciding the dates between the end of October, beginning of November in San Sebastian, and where we'll have our consortium meeting, and Tecnalia has agreed to the possibility of having also the host, to be in the host of the next workshop. We will probably invite also maybe another sister project, which is I started really recently. I don't remember the name. Iridion, I think. I don't. We can. There is another one. Okay, so I think we can extend it to other which are about hydrogen and PFAS free, I think, or simple clean hydrogen partnership. And I think that if we move just in time, we can also invite our program officers to maybe have an introduction to the workshop. Maybe it might be a good publicity also for them. Yeah, okay, we can discuss it maybe this later. What do you think, Maria? Would that be a good option?
Yes, I agree. I just put it in the chat.
Okay. All right. Yeah, sorry. Okay. Okay. So if there is no other comment, feedback, I'm very happy about this workshop and especially of the active participation. Thank you again for everything, and see you in 6 months with new results.
See you. See you.
Bye
Thank
bye.
you, everyone.
Bye.
Bye-bye.
Thank you.
Bye. Bye.
Okay, bye-bye.